Hi, today's Wednesday, November 25th, and you are doing a lesson on Edpuzzle today as you're watching this video. Your homework will actually be just completing the Edpuzzle questions at the end. Please make sure that you complete all of the questions and that you let the video play all the way to the end so that you get credit for this and it automatically grades in Schoology. For today, we're taking a look at our day 3 lesson, which is on the correlation coefficient. Our learning target today says I can estimate the correlation coefficient. And we've been talking a lot lately about looking at a scatter plot and recognizing trends. So today we're going to talk about what that trend means, the different directions that the trend has, but also how to assign a value that can help explain that trend. So I'd like you to take a moment to set up your Cornell notes for today. You may want to pause the video as you write things down before I move on to the next item. So day 3 is called correlation, and this should be the 25th today. And our essential question is, how do I estimate the correlation coefficient? So first, let's define correlation. Correlation is the strength and the direction of a linear relationship. It's important to note that there's two things that correlation describes. It does describe how strong the relationship is, but it also describes the direction, whether the relationship is that one variable is increasing as the other is increasing, or if one variable is decreasing as the other is increasing. The way that we describe the correlation using a value or a number is called the correlation coefficient. The coefficient is a number, just like it is when we're solving equations. The coefficient of the variable is the number in front of the variable. The correlation coefficient is a number that describes the strength of the relationship, describes how strong it is. We also use R to represent correlation. I don't have a good reason why we use R in technology. When we get into finding this actual value next week using technology, other than saying, you know what, in the word correlation, there's two R's, double R's. So what we have here is the R value describes the correlation. It's the correlation coefficient. So our learning target was being able to estimate the correlation coefficient, or the R value. So here's a kind of a scale that will help show what this looks like. When we looked at scatter plots, we saw that some scatter plots were very predictable. They were easy to tell where future points were going to go. Those are the scatter plots that have strong relationships. So what we have here is we have strong negative relationships over here on the left-hand side of this number line. We have strong positive relationships on the right-hand side of this number line, okay? So the stronger the relationship, whether it's positive or negative, means that it's going to be kind of out on the ends of this visual graphic here. When it's weaker, it's kind of in the middle of each side. So the middle of the positive side would be a weak positive correlation, and the middle of the left-hand side is a weak negative correlation. Now in the middle, where I've highlighted in orange, that's really kind of the area where there's not a good correlation between the variables. When we were estimating our line of best fit in the last lesson, we could see if the line of fit had a positive slope or a negative slope, or if it was too hard to tell what the actual relationship was. If we couldn't tell if it was positive or negative because the points were so scattered, it was a very, very weak or almost no correlation. So positive correlations, so these values between 0 and 1, are when the line of best fit would be rising, having a positive slope, okay? The R value is not the slope though. That's a common misconception. The R value has to be between 0 and positive 1.0 if it has a positive trend. And then as we see, the closer the positive 1.0, the stronger that correlation, meaning the stronger or the more predictable the data is, the more that it lines up. If it's a weak trend, it's kind of in between. So think about what numbers are halfway in between 0 and positive 1. So that's going to be like 0.4, 0.5, 0.6 is in this range. It's like 0.4, 0.5, 0.6. And anything above that would be considered a strong positive relationship, like 0.7, 0.8, 0.9, all the way up to 1.0 is a perfect positive relationship where the points perfectly line up. Then we have these other values between 0 and about 0.3 that would represent that, you know what, there might be a positive relationship if we checked it on a calculator, but it's not a very good one. It's like it's too weak to even tell it's positive. So that's what we have on the positive side. We have strong is close to 1, weak is kind of in the middle around 0.5, and almost no correlation is closer to 0, like 0, 0.1, 0.2, maybe even 0.3 would be considered like no correlation. And then on the negative correlation side, we basically flip that around. The stronger the negative relationship, the closer to -1 it is. So all of these R values from 0 to -1, excuse me, -0.1 all the way to -1 would indicate that on a scatter plot, your data shows a negative trend. Like our line of best fit would have a negative slope on it. So that means that our R value is going to be negative. But you can still have strong correlation even if it's negative. So if the data points line up nicely and maybe they even, let me draw a few dots for you. If I have a scatter plot like this, those dots line up nicely. It's not perfect, but it's a very strong relationship. It's very predictable. That would be something like in the -0.9 something range, like 0.99, sorry, -0.99. On the strong positive side, it would be very similar, just that the line is going up instead of going down. That's the only difference. They are both strong relationships, but the R value might be positive 0.99 for that one and negative 0.99 for the strong negative correlation. Okay, so basically it's the same concept, but it's just, you know, whether it's positive, that the trend is upward, you use a positive R value, or if the trend is downward, we use a negative R value. Let's look at a sorting activity to help us with this. So here's kind of our same number line. I even have the decimals in there to the nearest tenth. What we're going to do is we are going to order these 5 scatter plots by kind of moving them down into place. So what we want to do is on the negative side, we want to place any scatter plots that have a negative correlation. So what does that mean? That means that the line of best fit would be trending downward. So as I look at my scatter plots, I see an A, it kind of looks like the points kind of go up and back down. So that's not really, I don't want to say that's not really much of a correlation at all. Let's go ahead and just put that in the middle right now, because I can't really tell if that's going up or if it's going down. That one might have an R value of about 0. Let's see, for graph B, scatter plot B, I see that my points start. So on the left-hand side, I start up kind of at the top. And as I move to the right, the data kind of falls downward. So that definitely shows a downward trend. So I'm going to move that over here on the negative side, move it off to the left. Scatter plot C, they're scattered pretty good, but I can see an upward trend that, you know, on the left-hand side, my data points are kind of lower. And then as I move to the right, the data points are much higher. So it's rising. It has that line of fit that would be like a positive slope. So I know that it's a positive correlation. I'll just move that over here for now. Scatter plot D. Let's see, what do you think? Is that a positive or a negative correlation? We can see here that it's kind of falling. So it starts up high, and as you move to the right, it falls down. So that's a negative trend. And then scatter plot E, it rises. So that's a positive trend. So now we got to kind of compare these, comparing the two that were a negative correlation. Which one has a stronger relationship? Which one looks more predictable? Well, Scatter plot B definitely looks more predictable because look at those points. They all line up kind of nicely. It's not perfect, but they line up way better than D. Scatter plot D, the points are much more spread out. If I were to draw my line of fit on here, imagine that line going in between. Those points are not all right next to the line. They're too spread out. So B has a stronger relationship than D. So I'm going to put D at kind of above the weak negative correlation, and B I'm going to consider a strong negative correlation. We said A was basically no correlation because I couldn't tell if it was positive or negative. Now I have to kind of rearrange these and to order them. Think about which one's weak and which one's strong. Well, E, the points all kind of fit tightly. You could almost even draw a line through them, and the points would be really close to that line. So that means it's a strong relationship. Scatter plot C, I can tell it's positive, but the points are really spread out from that if I drew a line of fit. So what we have here is we have our weak positive is C, and our strong positive is E. So to estimate R values, kind of going to go through this left to right and just estimate an R value. And I'm estimating. I'm not saying this is the exact R value, but I'm kind of giving you a range based on the colors below on the number line. That if you look at a scatter plot and say, you know what, that is a strong negative relationship, we should be picking an R value or estimating something in that range of -1 to -0.7. Okay, so maybe it's not perfect. -1 is exactly perfect, like things line up perfectly like a linear graph. So I'm going to say this one's about -0.9. It's a pretty good relationship, and it's negative. So I want to show that with my R value, my correlation coefficient. Now for scatter plot D, that's where we have a negative correlation. It's weak though, so it's somewhere in this yellow range from -0.3 to -0.7. I maybe say, based on what I see here, and I've done some of these on calculators, I can tell, I'm going to say this is probably more like a -0.6. But if you were to estimate that to be -0.5 or -0.4, that's okay too. As long as you're recognizing that's weak, negative, one of these values in here would be okay. A is one of those where you can't really tell if it's positive or negative. It's kind of in between. So I'm just going to say about 0. If I did this on graphing calculator and using technology, it wouldn't give me exactly 0, but it would be in between probably the positive 0.3 and -0.3, somewhere in that area to indicate correlation isn't very good. Scatter plot C, we had that positive trend. The points are scattered, meaning it's a weak correlation. Now, if you compare it to D, is scatter plot D stronger or weaker than scatter plot C, or maybe even about the same? Kind of looking at the two, I'd say they're pretty similar in terms of how strong the correlation is. The only difference is that scatter plot D had a negative trend, scatter plot C has a positive trend. So I am going to apply the same strength, but just show that it's a positive 0.6 instead of a negative 0.6. On scatter plot E, I do have that positive trend. It's pretty strong. If I compare it to scatter plot B, I'd almost say that scatter plot B is stronger. If I actually drew a line of best fit here, I'd say that those points are really, really close to the line. Scatter plot E, they'd still be really close to the line. I just feel like they're just slightly more scattered, just a little bit, not a lot, but just a little. So I would use a value that shows that it's not quite as strong as the other one that we used a 0.9 on. So I'm actually going to say in between, I could say 0.8. I'm going to actually go in between 0.8 and 0.9 because you can do that. I'm going to say it's about 0.85 to show it's not quite as strong as this one was, that one that was -0.9. So just a little bit less than that at 0.85. Okay, but still positive numbers, positive R values if your trend is going upward, negative R values if your trend is going downward. All right, so here's where you guys get to show me your learning. So in our check for understanding, problem number 1, you're going to see a question pop up here in just a moment. In Edpuzzle, you are going to answer using your 4 choices. what do you believe is the best correlation coefficient for number 1? What do you feel like is the best correlation coefficient for number 2? Please respond by choosing your answer in Edpuzzle. What do you feel is the best correlation coefficient, or R value, for scatterplot number 3? Choose your answer in Edpuzzle. Number 4, please choose the most correct R value in Edpuzzle for your correlation coefficient. And finally, our last problem, number 5. Please choose the most correct answer for the correlation coefficient in the Edpuzzle.